Today we are going to be talking about 9.6 B, and we're diving into permutations. So we talked about combinations before in terms of people and order and stuff, but here's the big difference between permutations and combinations. So combinations, we kind of throw people into a group and the order does not matter. Whereas in permutations, it matters. Order matters. So in permutation, the order of the person and where they stand matters. And in combinations, it's a lot more loose. The order doesn't matter. You're just lumping things into a group. So with combinations, the possibility is a lot less because you're not counting each and every single specific type. We are counting just the groups. Permutations, we are counting the specific types. So let's say we had, for example, let's say we had 4 people running for office, and we'll name them Ruby, Bob, George, and Yoda. And I'm going to represent these as different colors. George is green, Yoda is yellow. And they can be either be win vice president or vice president of the class. So there's only two winners can only happen, and we want to know how many permutations of that is possible. So here, let's say Ruby wins. So Ruby wins this first scenario. Well, Ruby could have a vice president of Bob, George, and Yoda. In the second scenario, Bob wins and is president. Well, Bob can have a vice president of Ruby, George, and Yoda. Then George could have won. George's vice presidents could be all these following of Ruby, Bob, and Yoda. Or Yoda wins, and their vice president is Ruby, Bob, or George. So here we can count how many it is individually because the numbers are pretty small. And this is a 3 by 4, so there are 12 permutations of this outcome. If I wrote this as a actual permutation, this would be 4 pick 2 or 4 permutation 2. I like to say P pick 2, 4 pick 2. In terms of our permutations, there were 4 possible people. We could only pick 2 of them. What are the permutations? There are 12 of them. Another way that we can analyze permutations is using factorials. So here, this will allow us to analyze the bigger permutations of our factorials. And our formula is, let's say 4p2. Our formula is our number, and this is n, and this is r. So NPR. So n factorial is divided by n minus r factorial. So here, this is 4 factorial divided by 4 minus 2 factorial, or 4 factorial divided by 2 factorial, which is, this takes out the 2 factorial. So this is 3 times 4, which gives us 12 as our permutation. Let's do another different type of permutation. And let's say we had a group of letters, and we want to know how the permutations of the different types of combinations that we can permutations that we can have with that. So let's say we have the word algebra. Nope, spelled it wrong. So here, what we want to do in order to analyze this is using our factorials. The numbers, we take the number of factorials on top and we divide by each individual number representative factorial on the bottom. So the number of digits or letters on top, let's say 1, 2, 3, 4, 5, 6, 7. So this is actually 7 factorial on top. A's, there are 2 of them, so we want to divide by 2 factorial. L, there is 1 of them, so we don't really need to divide by 1 factorial. It's just 1. So L, G, E, B, and R all have 1 factorial, so I'm just going to stick with just the 2 factorial. So if I reduce this, right, reduce this with the 2 factorial, so this leaves me 3 times 4 times 5 times 6 times 7 on top. Multiply that out, we should get 2,520 different types of permutations of the letters in algebra. Let's do another one, and let's say we did for the word race car, and we want to know how many permutations can we have of the all the letters in race car. So there's 1, 2, 3, 4, 5, 6, 7. There's 7 letters in race car, so we'll do 7 factorial on top. Starting with R's, there are 2, so we divide that by 2 factorials. A's, there are 2, so that is 2 factorial. C, there are 2, so this is 2 factorial. E's is 1, and we have A and 2. So let's write this out. So this 2 factorial right here, this will get rid of a 2 on the numerator. So that gives me a 3 times 4 times 5 times 6 times 7. But we still have the 2 factorials here. So this is 2 times 2, which will reduce with the 4 to make 1. So we actually only have 3 times 5 times 6 times 7 as the amount of permutations, which is actually only 630 different types of permutations of the word race car.